So here's another example. This one is much more difficult and much more involved because I have an x to the 5th. And so there's going to be a lot of finagling to find out what my 5 zeros are. Okay, so what I'm going to start with, I really can't factor this just looking at it. So I'm going to start guessing at what roots can be. And this is where the rational root theorem comes into play. Okay, it tells me that the factors of 8 over the factors of 1 are all possible roots to this problem. Okay, so we have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and they're all over 1. Okay, so I have 8 different possibilities that I can try. So I worked ahead of time, and I already know which ones work. So first thing I'm going to do is I'm going to try 2. Okay, and remember here, we don't have an x to the 4th power, so we've got to make sure that we throw that in there. So we've got 1, 0, 1, negative 2, negative 12, negative 8. All right, so the 1 drops. 2 times 1 is 2. I add those. 2 times 2 is 4. I add those. This is 10. 8. 2 times 8 is 16. We subtract that and get 4. And 2 times 4 is 8, which gives me a remainder of 0. So one of my zeros, one of my solutions is 2. I'm just going to write it up here. X equals 2. All right, but now I'm down to x to the 4th plus 2x to the 3rd plus 5x plus 8, 5x squared plus 8x plus 4. Okay, I need to do the synthetic division again. Okay, now if I take this out, I do 1, 2, 5, 8, 4. If I get those coefficients out, it's the same thing as up here. So really, I can skip this step because I'm just going to use this again. It's kind of like stacking my synthetic division. I'm going to use it again, and this time I'm going to try negative 1. So negative 1, we drop the 1, this is negative 1, 1, negative 1, 4, negative 4, 4, and negative 4 gives me 0. So now I have x to the 3rd plus x squared, actually I'm going to write it over here, x to the 3rd plus x squared plus 4x plus 4. Now, if I can't factor this, then I would need to do synthetic division again. But if you look closely, this one you can factor by grouping. Okay? So we pull out an x squared. I'm left with x plus 1. Okay? Pull out a 4 and I am left with x plus 1. So I have x plus 1 times x squared plus 4 equals 0. So right now, let's just take a break for just a second. Right now, I know 2 of my zeros. I have 2 solutions. One of them is 2, and one of them is negative 1. And I know this because I got zeros as remainders. Now I'm coming here, and I'm going to find the last 3, okay, because there's a total of 5, right? There's a total of 5. I'm going to find the last 3 with factoring here instead of synthetic division. So I can see with this one that another one is another negative 1. And this last one, x squared plus 4 equals 0. If I subtract 4 from both sides, I get x squared equals negative 4. I take the square root of that, and I have x equals plus or minus 2i. Okay, so I have 2i and negative 2i. And those are my five roots to the problem, my 5 solutions. Hopefully you also recognize that negative 1 is repeated. So that means it's going to bounce on the graph. So let's look at what that graph looks like for this one. So remember it's positive and it's odd, so it's looking like this. So it comes up, this is all negative. It bounces off of negative 1, comes down, and then comes back up through 2. Well, these are my real solutions. 2, negative 1, so it bounces. And then my 2 imaginary numbers. So if I showed you this graph and said how many real roots are there and how many imaginary, you would tell me there are 3 real roots and 2 imaginary. And I know that there are 3 real and 2 imaginary because they have to equal 5. Okay, my last example. This is very, very similar to what I did in the last lesson. This is where we work backwards. They give us the roots, and we have to come up with the polynomial. And so, write a polynomial function f of least degree that has rational coefficients, a leading coefficient of 1, okay, and the zeros 2 and 3 plus I. Well, I know that if I've got 3 plus I, I'm also going to have 3 minus I. And remember, these are kind of packaged numbers. So I have x minus 2, that takes care of this one. I have x minus 3 plus I, that takes care of this one. And finally, I have x minus 3 minus I, which takes care of that one. All right, so x minus 2 is just going to hang tight for a little bit. Remember, I distribute the negative, so I get x minus 3 minus I. Over here I have x minus 3 plus I. And then I'm going to restructure, regroup what I've got in here. And I do that by throwing parentheses around these first 2 terms, because they're exactly the same. And now I have an a minus b times a plus b situation. So a plus b times a minus b is a squared minus b squared. So I take the square of the first one minus the square of the second, which is I squared. Okay. Now we just start cranking things out. Okay, x minus 3 squared is x squared minus 6x plus 9 minus I squared is negative 1. Okay, so this is actually going to be x minus 2 times x squared minus 6x plus 10. And now I just multiply through. So this is, if I distribute the x, I have x cubed minus 6x squared plus 10x. And now I distribute the negative 2, I have negative 2x squared plus 12x minus 20. And now when I combine like terms, I have x cubed minus 8x squared plus 22x minus 20. Okay, so if I factor this and I find all the roots, there's 3 of them. Okay, here they are, 2, 3 plus I, and 3 minus I. But I would get those answers again. Okay, so that's what I have for you. These problems are long and they're very involved, but I know you can do this. Okay, just take it one step at a time and you will get the answer. So tomorrow, or I shouldn't say tomorrow, when we meet again, I'm going to go over some of these homework problems when I see you next. Remind me if I don't. But hopefully that will help you finish some of that homework. Okay, so let me know if you have any questions.